In this example, we will approximate the values of different radical expressions by determining which two integers the following irrational numbers fit between. We will do this without using a calculator. We will state this as a three-part inequality. In part A, we are going to be working with root 10, or the principal square root of 10. The way to begin this is to first determine which two perfect squares does 10 fit between. Specifically, what are the two closest squares, one less than and one greater than 10? Well, I know 10 is less than 16, and I know 10 is greater than 9, 9 and 16 being the closest perfect squares. So if 10 falls between 9 and 16, then we know the square root of 10 must fall between the square root of 9 and the square root of 16. By having picked perfect squares with the 9 and the 16, I can simplify this statement to say that 3 is less than the square root of 10, which is less than 4. We have now approximated that 10 is somewhere between 3 and 4. Because 10 is closer to the 9, we can at least estimate that the square root of 10 will be closer to 3 than it is to 4. We're going to skip part B for the moment and jump to part C. In part C, the expression we're working with is root 18 all over 2. To begin this one, we're going to first focus on the 18 and find the two perfect squares that 18 sits between. I know 18 is greater than 16, and 18 is less than 25, 16 and 25 being the closest perfect squares to 18. So because of that, I know that the square root of 18 will fall between the square root of 16 and the square root of 25. Another way to phrase the same statement is that 4 has to be less than the square root of 18, and the square root of 18 has to be less than 5. So root 18 fits between 4 and 5. Taking into account that we weren't dealing with root 18, but rather root 18 over 2, I can go a step further. I can divide all of those values in half. So that would then further tell me that 2 is going to be less than the square root of 18 over 2, which will be less than 5 over 2, which is the same thing as 2.5, or 2.5. So this goes a bit further than the directions had indicated, which was to determine which two integers these numbers fall between. We've actually narrowed it down even further, that root 18 over 2 must be between 2 and 2.5. If we really wanted to keep carefully to the directions, we could take it a step further, because we know 2.5 is less than 3. So we could expand it out further to say root 18 over 2 is between 2 and 3. But honestly, 2.5 is a little bit more restrictive and a little bit more precise. On part D, we have the opposite of the square root of 84. Again, we'll start by focusing on the radicand. We want to pin 84 between two perfect squares. I know 84 is greater than 81, but less than 100. So that tells me then the square root of 81 is going to be less than the square root of 84, which will in turn be less than the square root of 100. But by picking 81 and 100, I can simplify the statement to say that 9 is going to be less than the square root of 84, which will be less than 10. So root 84 fits somewhere between 9 and 10. That being said, we were not asked to work with root 84, but rather the opposite of root 84. So using what we know about inequalities from previous courses, something that hasn't truly come up yet in this course, is I want to actually change the sign on all of those numbers. I want to change this to a negative 9, a negative root 84, and a negative 10. One of the rules we hopefully remember is, if you take an inequality and you multiply both sides of the inequality by a negative 1, so I'll multiply the 9 by negative 1, I'll multiply the root 84 by negative 1, and I'll multiply the 10 by a negative 1, not only does it change the signs there, but it also has an impact on the inequalities. So if I need to state this as a three-part inequality, I need to be able to say that negative 9 is greater than negative root 84, which will in turn be greater than negative 10. Now having discussed that, let's come back to part B. In part B, we are dealing with 1 minus root 17. We will begin with the root 17. By focusing on 17, we will first pin 17 between 16 and 25, similar to what we did with the root 18 in part C. I know 16 is less than 17 and 17 is less than 25. So then in turn, I can throw a root over each one of those. So root 16 must be less than root 17, which in turn is less than root 25. This will simplify down to 4 is less than root 17, which in turn is less than 5. So that's focused on just the radical piece. But now taking into account the fact that we actually want to work with the negative root 17, I'm going to end up multiplying each one of those by a -1. -1 times 4, -1 times the root 17, and a -1 times the 5. But remembering when we change the sign on the values, we also change the sign on the inequality, meaning the inequality gets reversed. So another way to say that if I know 4 is less than root 17 is less than 5, I can reverse that to say then -4 must be greater than negative root 17, which must in turn be greater than -5. The original expression we had was 1 minus root 17. It's important to recognize that 1 minus root 17 is the same thing as negative root 17 plus 1. So if I can add 1 to each one of these expressions, -4 plus 1, negative root 17 plus 1, -5 plus 1, I'll actually finally arrive at what I'm trying to figure out. -4 plus 1 is -3. Negative root 17 plus 1 is 1 minus root 17. And -5 plus 1 is -4. So through several steps of work, by starting with the radicand and pinning the radicand between two integers, taking into account we're actually dealing with a negative root, and we really wanted one more than that negative root, I have now identified that 1 minus root 17 will be somewhere between -3 and -4.